Yes, guys, good morning. Today I'm doing a video in the morning time. Today is weekend, Sunday, so I have a time for video in the morning time. And I'm really very much happy to bring up this project to you guys. This is very much important project other way because this is a resilient multi-region real-time project. Multi-region. And if you put this project in your resume, I believe you will never fall in the problem for job scarcity. You will never be unemployed in the cloud DevOps. I believe this. Very few projects I have in the mind, which ones are by battery. Okay, so I suggest guys, it will be hard, honestly hard at the starting, but if you do this guys for just one day repeatedly, at least 4 or 5 times, if you see this video, then it will be helpful for you guys. This is the MSK, Amazon Managed Streaming for Apache Kafka. This managed MSK, Kafka. So Kafka is vast, it's large, honestly. So if you know this Kafka here is miniature, okay, at least you have the practical knowledge, hands-on knowledge with Kafka. So it will be really helpful for you. And here I have added lots of things. See here, MSK, Spark streaming, DataSync, and failover handling. Okay, Spark streaming, DataSync, also failover handling with Kafka, managed service Kafka Amazon. Man, scaling really awesome. I have a suggestion. Please try, practice this one. If you don't like my this content, no worries. You should try this one from your resources also. If you want to keep your cloud journey, your job for your rest of the life, I would suggest please keep this line in the resume that I managed resilient multi-regional real-time project. Which one? I deployed data pipeline on AWS. So here is analytical data pipeline. You have the analytical knowledge. Your recruiter will be happy. Your interviewer will be happy. Oh, this guy knows also data pipeline. Honestly, this is not the analytical like that. If you say like this, that means you're the neighbor of data science. You know data. Such kinds of impression will have. So I'll suggest please try this one. And this is the MSK you saw. And what is the MSK? MSK managed streaming for Apache Kafka. If you go to the image here, so I like this image. First of all, just see this one. This is the simple one. First, here, Kafka client, Amazon managed streaming for Apache Kafka. Then this is the MSK. Then AWS Lambda, that means API call. Then Amazon DynamoDB. So this is the client, Kafka client. This is the user, right? User pops up, publishing the messages. Hey, I need the food in the DoorDash. Hey, I need the ride in the Uber. So like this kinds of message is giving, or in the like WhatsApp or anything as message to giving the dear person. So this kinds of message is coming with the Kafka. Then it's going like this way. And another picture, I like this picture also. This one. This picture is here. Kinesis data streaming or Amazon MSK. So data streaming, how this has happened? User click streaming data. Here, see first. User here, gaming platform, Internet of Things, IoT. Either way, here is the user, right? Then it's going to Amazon Kinesis data streams. Or here is the MSK. Either way Kinesis or MSK. Which one is used in your project? So it depends upon your PO, upon your roles and policy and compliance in the project. So here is Amazon Kinesis data analytics is coming both way. Kinesis or MSK is going where? Analytics. See here in the Kinesis data analytics, they are together. Then from here, if MSK is going like this, Amazon MSK. If Kinesis is going like this, Amazon Kinesis data stream. See here, data stream is still here. This is MSK is here, and this is the Firehose. And here is the one more Amazon Kinesis data Firehose is here. Amazon MSK Connect. This is the MSK Connect, Elasticsearch Sync Connector. So MSK needs connect or connector, but Kinesis, if the Kinesis is coming, then Kinesis needs Firehose. Then here is Amazon Lambda calling with Kinesis Firehose. But connector straight to Amazon OpenSearch is going to OpenSearch. But for Lambda, it's going to straight where? S3, Redshift, or also OpenSearch. So MSK, so Kafka is going only the OpenSearch. But here, Kinesis is going to the S3 Redshift. Keep in mind, think simple. I'm giving you the simple point. For the data pipeline, if you say like that, I have used a project or two projects like that. One project has the MSK, another project has Kinesis, and both project uses the Amazon OpenSearch also, but Kinesis used in the S3 data lake and also Redshift. How the Kinesis and MSK differs, just know that how it differs. And MSK connect with OpenSearch with connector, and Kinesis connecting with S3 with Lambda, S3 API, Lambda calling, or Redshift, or either way Kinesis connecting with Lambda, also OpenSearch is coming with Lambda. So this is the way it's working. Think simple and make any kinds of complex easier. Okay, so here is this one I showed you, and this is my GitHub. Here I will add DevOps 0 to Hero. I'll add here. This is my LinkedIn. If you like, you can connect here. It's my YouTube, and here I already uploaded lots of videos, but if you like to know AWS DevOps engineering, start from here. 3-tier deployment with VPC. This is also masterpiece, honestly. So from here, then this one, just follow this chronology from there. Also lots of Kubernetes, also everything whatever needed, almost is still not finished. I try to have here, and this is around $25,000 in the USA discourse, still not finished. Okay, so let's see here first project overview. This project sets up a multi-region real-time data pipeline using Amazon MSK, Kafka, Apache Spark streaming on AWS EMR, Elastic MapReduce, and AWS DataSync for cross-region replication and automatic failover management via AWS Lambda, data storage, monitoring and visualization with RDS, DynamoDB, CloudWatch and QuickSight, enable resilience and high availability. So if you could memorize this sentence, I think this paragraph, just diamond. Honestly, I can't memorize. I just memorize like that. Kinesis, Kafka, how this is connecting. Okay, with OpenSearch one, or Kinesis connecting with S3 API, Redshift, Firehose is there. Like only that few things I keep in my brain. But I think I assume you are much smarter than I. Of course, you should be. Then please try to memorize this paragraph. Then implementation steps is here. Step 1, I am keeping them like this one. I'm making the color this one. Okay, so set up MSK cluster in multiple regions. Navigate to Amazon MSK in the AWS Management Console. Select your primary region and choose Create Cluster. Configure cluster name, broker, instance type. When Kafka coming, Kafka has the broker. Okay, so this is like a share market, right? Broker. So it should be Kafka.t3 small. How can you memorize the Kafka instance? Like RDS has which one? RDS has also like this data dot or db dot t3 small like that. So in the place of db, just place in mind, I keep in mind Kafka dot t3 small, t3 medium like that. Then storage per broker, see broker 2 GB EBS. Then encryption in transit. So in transit encryption is needed, enable. Transit means from the customer to the provider, in between the long distance SSL certificate, So those kinds of encryption should be had. If any kinds of hacker in between taking the hacking, my goodness, everything's messed up. Then configure network and security, place broker in private subnets within a VPC, See here, broker should be private subnet. My goodness, I'm keeping it red. Where is red? This one. So broker is in the private subnet. Set security groups to allow communication between MSK, EC2 instances and EMR. Security group, SG. Always you're doing very good job. Everything is done, finished, but you can't do connection. It was problem with me. I was frustrated. Then my manager said, oh, see the security group. Oh my goodness, the security group allowing. Always don't allow all traffic. Always don't do that. But normally we are doing all traffic inbound. Okay. So this security group, and create secondary MSK cluster. So you have to do secondary also in another region. See here which one? Another region should be. That means your customer is in another region. Repeat the above steps, configuring a secondary cluster in a different region. Configure cross-region replication. So use Kafka Mirror Maker to replicate data from the primary MSK cluster to the secondary region. So here is the Mirror Maker. Launch an EC2 instance in the primary region and configure Mirror Maker to read from the primary and write to the secondary MSK cluster. See here, it will be reading from which one? From primary, but writing to the secondary MSK cluster. So reading then writing like that. Set up secondary groups. Ensure security groups allow access across regions and enable required ports. Like this is the required ports 21819092 for cross-region communication. Then set up Kafka client EC2 instance in both regions. Launch Kafka client EC2 instance. So before that, let's see one more time. Where is this one? Here. If you come here first, create cluster, then connector. Can you remember the connector here? We showed you the connector, right? This is the connector. See, MSK Connect, Elasticsearch Sync connector. So here you have to create also connector. First, you have to create the cluster. Which cluster? This is the MSK cluster. First, you have to create. After having inside everything finished up, coming here, everything done, then you have to have the connector also. So here, create cluster. So like that, demo cluster like this one. Cluster type serverless provision. If you like to provision, you have to provision like this way. Apache Kafka, like this is going the recommended one. Then broker size. This is the large, right? Oh my goodness, too much money, man. It will take. Okay, no, isn't that T3 is small? Okay, we are doing like this way. Okay, we recommend 300 partitions for per broker. Okay, T3 is small. If you need more partition per broker, use M5 broker size. We are just with the T3 now. Storage 100 GB. Okay, then setting up all clusters. Cluster type provisioned. Editable after cluster creation. No. Apache Kafka version, this is 3.6. Please memorize which version is going on, because this is important in the interview. If you say that I have used the Apache Kafka in the AWS MSK, then first question will be interviewed, okay, which version? You will be smarter also. You say 3.6. Oh man, that's good. The metadata mode, zookeeper. Okay, this is the zookeeper. Maybe lots of animals, right? No, this is interesting. When I first learned zookeeper, I was really laughing too much. Okay, cluster configuration, MSK default, VPC, this is the default VPC, subnet, these are subnets, it should be private subnets, but my subnets are here, all the public, okay, because in the default I did not made any private. Public access is off, it should be off. Security groups associated with VPC, this is the SG, security groups. Zones, how many zones here? 3, right? We should be 2 also, here, right? We should be actually customize this one. Broker size Kafka.T3 small. This is the broker size. Then broker per zone is 1. Cluster storage mode, EBS storage only. So storage is here, EBS, Elastic Block Service. This is very much secured. Storage 100 GB byte. Then provision storage throughput per broker not enabled. Access control method IAM. Then encryption within the cluster enabled. TLS. So TLS, encryption between client broker, also TLS. So encryption cluster TLS, client broker, also TLS. Then here is encryption for data at rest, Amazon MSK managed, CMK, monitored metrics default, basic one, open monitoring with Prometheus not enabled. Then broker log delivery not enable. You can do enable also in the real time. So if you create here for create a cluster, it will take 15 minutes. Okay, so always the cluster, what kinds of cluster you are creating, also the EKS Kubernetes cluster, it take the 15 minutes in the Amazon. This if the subnets that appear in the all cluster settings tables are in unsupported zones, Amazon MSK retries the cluster creation operation with subnets in supported zones. That's the beauty. If any kinds of problems, if already in the unsupported zones, it will just transfer or transit to the supported zones. So this is the basic thing for creation here. And yeah, let's go to the next part. Set up the Kafka client EC2 instance in both regions. Here is the two regions we are showing up here. Launch Kafka client EC2 instance. Deploy t2.large EC2 instance in both regions for Kafka client operations. Here is my region is which one? Virginia, Northern Virginia. So one should be Northern Virginia, another one should be another places. Maybe in Oregon. We are using vastly in the USA like that. So here install Java and Kafka on each EC2 instance. So Kafka needs Java. Guys, very few resources in the Amazon or very few client needs the Java. So Java, which one I have used, Kafka and also Jenkins. Also I forgot some names, but Kafka, MSK and Jenkins needs the Java. Then SSH in okay on each EC2 instances. Yes. So SSH in each instance using Mobextram or similar. Okay, you know everything. Sudo apt update. So this is the important how to do the Java install. Open JDK 8 JDK like that, or 11, which one is available. Curl. So you have to call this one. Which one? Call Kafka API. This is the curl when coming, that means API. It will download the Kafka version. Then this is the zip file, you know, TGS. Then you have to unzip with tar. So then you will get your Kafka folder or directory like that name. Configure a Kafka client security SSL. Generate SSL certificates if needed. So configure client.properties security protocol equal SSL. This is going like that. Okay, everything is obvious. Set up topics. Yes, Kafka needs broker needs topics. Okay, topics means message actually, what kinds of messages. Then enable automatic failover. Okay, failover means if failed one message, then it should be automatically resent. Failover should be. Create Kafka topics in MSK console or via CLI. From EC2 client, use command to create topics. This is the Kafka topic like that. Create zookeeper. You have to create the zookeeper here. So here the partition you have to have. Configure automatic failover with AWS Lambda. So here the Lambda is coming for failover. So normally Lambda we don't use, but for failover, keep in mind. Please memorize or just recap. See here in the Kafka MSK, here we did not use which one? Lambda. But for failover, if this is failed, not connected, then we are calling to Lambda. Okay, so we should know this way how to make sure your high availability or resiliency. Okay, we said that resilient, right? Keep in mind your name, resilient. When you say the resilient, this kinds of word, that means high availability. When high availability, if failed something, so high availability or resilience is achieved through if failed something, then you have to create something other way. So if failover is happened, then the Lambda calling, create Lambda function. So Lambda when always working with a function, Lambda function. So to monitor MSK cluster health via CloudWatch. Monitor coming, CloudWatch is coming. Configure Lambda to detect if the primary MSK cluster goes down. So Lambda will detect, okay, CloudWatch or Watchdog Lambda. So Lambda detect if any kinds of failover is happened down. I'm making this one red. Then automatically update client configuration to point to the secondary MSK cluster. So if one region is failed, another region is going. That means failover. When failover is coming, just memorize it works with two regions, two edges also. But vastly failover works with regions. One region down and another region. And it's never happened that both regions are down. This is good thing. I don't know in future maybe happened or not. Okay, but I pray it will not be happen. Okay, so yeah, automatically update client configuration to point to secondary MSK cluster. So lambda zero code is here. Import boto 3 like this. I'm making this one bold. So here the lambda which on the function, when you create in the lambda function, you have to give the code inside handler to create the handler, import boto 3 lambda handler. Okay, when coming function, that means handler. Event context, please memorize these two guys. Actually, I'm saying myself, I sometimes forgot. So in the interview, when the question is coming or word is coming from lambda, yes, I created lambda function with lambda handler inside event context. Oh man, you just pro. Okay. Check primary cluster status. This is just comment. MSK. Then you imported boto 3 right here. So MSK equal or assign boto 3 dot client Kafka. So when you're importing boto 3, then just doing like this way. Primary cluster status MSK described like this way is going rn. If primary cluster status state cluster info state active, see here active. Okay, trigger failover to secondary, update client to secondary. Okay, normally active is always. If not active, unfortunately, if not active, then it will call the secondary one. So lambda handler always remembering the positive something. If negative, then start from the start, it will be stopped. But if the active is showing the active, that means, oh my goodness, my primary region is failed. Okay, I have to go to secondary region. I should be active, man. So lambda talking like that. Then update clients to secondary. Update clients. See here, update clients. Same way here, we saw which one? Update client, right? Like that way. Then step 4, deploy Apache Spark streaming on AWS EMR in multiple regions. See here, multiple region is coming. Which one is coming? EMR. Now we are here, EMR. Set up EMR cluster in each region. In the EMR console, create cluster in both primary and secondary regions. Cluster name Spark EMR, like this way. Either way you can change. Then applications Spark Hadoop. Instance type, start with a similar instance size, M5 XLARS. You can change also either way. No need for the similar always. And then enable auto scaling to adjust to data load changes, guys. Making simple. When coming EC2 word, auto scaling load balancer, security groups, keep in mind like that. Okay, because AWS honestly vast, so sometimes it will make you frustrated. Oh, I can't memorize. Oh, it's too much resources, too much services. It's killing, man. See here, which one? EC2, right? Go to EC2 here. I'm making something easy for you guys, because you have to appear also for the certification sometimes. So this kinds of question is coming. When EC2 is coming, here is no EC2 is running here. So when EC2 this one is coming, then see the left panel, instances, right? Then images, AMI. Then coming EBS, block storage, volume. Okay, networking. Here is coming networking, elastic IP, security group, placement groups, keep here, network interfaces. So VPC's portion is here, portion, not the entire VPC. Memorize portion, networking with the EC2. Which one is needed or required? Then load balancing, whole load balancing is here. Normally load balancing we feel, oh my goodness, too much bigger, right? Too much bigger. Actually for me, sometimes when I was new, oh, load balancing killing, too much bigger. No, it's not too much bigger. Load balancing needs targets group. Just make the target group, this target, this kind of EC2, this kinds of EC2, okay? Then just added the target group in the load balancer. Then auto scaling, this is the auto scaling groups. So auto scaling means many EC2s. It cannot be with only one EC2. It should be more than 1, 2, 300,000 EC2s. Okay, I never worked with 1,000 EC2s. I worked with more than 200 EC2s, I think. No, 400, I think. So yeah, maybe some guys have the 1,000 EC2s. Then the auto scaling coming, number of EC2s, auto scaling. And for the scaling up is coming with the EBS volume. What is EBS? The EBS volume. Scaling out is coming with auto scaling. Up for EBS, up, and out, that means more. That one is for auto scaling. Keep in mind, learn one time, use lifetime. Okay, easy man. Okay, then here, so enable auto scaling. Okay, ensure that the security group EMR cluster allow inbound and outbound communication with MSK cluster. So you have to see also that one. Also create deploy Spark streaming job, upload the Spark job to an S3 bucket, submit the Spark job in EMR console. So in the EMR you have to have the Spark also. Configure a consume data from MSK cluster and process it in real time. Persist process data in AWS database with cross-region replication CRR. This is the CRR normally called. I'm making like this CRR. Okay, select database storage. Use AWS RDS for structured data, DynamoDB for NoSQL, or S3 for raw or processed data storage. Then don't be confused about S3 raw and processed. Just keep in mind, S3 can store any kinds of raw, processed, unraw, new, old, any kinds of files, any kinds of. Okay, so sometimes it makes problem. Raw, processed, S3, no, any kinds of data in the S3. Enable CRR replication. Enable replication across regions for high availability. Why CRR? Why replication should be for high availability? Because the failover. When failover is happened, it should be transferred or rerouted to the another region. Step 6, multi-region data synchronization with AWS DataSync. So abbreviation of synchronization is here, sync. Goal: ensure that data remains synchronized across multiple AWS regions, providing consistent data availability and redundancy. So you made cluster everything for multi regions, but data not synchronized with the database. Man, killing man. So be careful about synchronization. So when synchronization is coming, DataSync is coming. Vastly, this word. Set up DataSync agents. DataSync requires agents to be set up for handling cross-region data replication between AWS resources. Launch DataSync agents in both regions. In both the primary and secondary AWS regions, navigate to AWS DataSync. Create agent. So now the agent has come, and see here, before the agent you have to make sure the DataSync is created. It's coming DataSync here. Let's see here, DataSync. Okay, DataSync left panel, see here, location, task history, always see this one. See here, agent. DataSync needs agent. Create the agent. So here is the agent. Which agent you have to create? Like this. Then service endpoint. You have to give the endpoint service, public service endpoint in Virginia, or either way. Activation key. So automatically get the activation key from your agent, or manually you can do. So manually also you can do this one, activation key, or automatically is normally doing. So here, which one is set here? If syncing data from on-premise location, download and deploy DataSync agent on an on-prem server for cloud-to-cloud transfers. AWS manages the setup, so no agent download is needed. So no agent when needed. When this is done, cloud-to-cloud transfer, AWS manages on that time, set up automatically. This is important. Then choose the Amazon EFS, Elastic File System, S3, Amazon FSx as your destination or source depending on where your data resides. Configure DataSync tasks. Go to AWS DataSync tasks and click create task. You have to create then task when your DataSync has come. Then specify source location. Select the source location where your data is stored, like an S3 bucket, EFS, or FSx. Specify destination location. Set the destination location in the secondary region. This can be the same type of service as the source. Task options. Choose options like data transfer frequency, daily or hourly. Enable incremental transfer to transfer only changes files, optimizing cost and efficiency. Automate DataSync with Lambda. Create AWS Lambda function to automate DataSync tasks. Lambda function will be triggered by S3 events when a new file is uploaded. Okay, file is uploaded where? S3. So when this is done, then S3 API. See, S3 API, I said in my earlier videos lots of times, S3 API is the key word for CLI command. So here S3 API will create the triggers. Set the Lambda function to initiate DataSync tasks whenever it detects new or modified files. Example, Lambda code is here. Import Boto3. I'm making bold this one. Okay, def Lambda handler. So here is the event context same coming. Client Boto3.client DataSync. Lambda handler. See here is the DataSync. And earlier Lambda handler was which one? Can you remember earlier one? Where is, I forgot, man. What is Lambda handler? Our earlier one. Okay. Earlier one was which one? Kafka. See here, it makes like kind in the Kubernetes kind. What kinds of thing is here? Okay. This is the identification. Here is the Kafka. It's making the Kafka Lambda making. So here is the which one? Client. So client Boto3.client again. Then DataSync client is coming here. So handler, event context, then client. So client name, response. Client.start, task execution, task ARN. This is the your DataSync task ARN. I'm making this one unbold because it will be varied, you know. Return response. This is important. Return. So you have to write return response, then it's working. Test the automation. Upload a test file to the source location and verify that it syncs to the destination. Monitoring and visualization. Goal. Set up monitoring and visualization tools to gain insights into system performance and data flow, allowing proactive responses to potential issues. You have to set up the goal like that. Monitoring. Monitor with AWS CloudWatch. Set up the CloudWatch metrics, Amazon CloudWatch and metrics. Then configure metrics, MSK. MSK when coming, then broker CPU utilization. So when CloudWatch coming, that means CPU utilization coming, right? So which one? Broker memory uses, also memory uses. So honestly guys, when the utilization coming in mind, CPU uses memory. So CPU is like the body, you know, body. Memory is the brain. So brain uses, memory uses. So this is interesting. Okay, you have to create your ways how to memorize some keywords. So utilization, CPU utilization, memory and uses, memory uses. For this, for myself, how I memorize in my brain like that. So then EMR, Spark for job duration, error rates, RDS, DynamoDB or other database services for monitoring, read write, IOPS, latency. So here is the setup custom CloudWatch alarm when CloudWatch is coming. CPU utilization, memory uses, also the alarm. Without alarm, you can't do anything else. You cannot know notification like that, you know. So for instance, create alarm to notify if mask broker CPU utilization exceeds 80% or not, like that. Then integrate with Lambda for automated alerts. Create a Lambda function to respond to CloudWatch alarms. For example, if a high CPU utilization alarm is triggered for the MSK broker, Lambda could automatically initiate failover or increase resources, like that. Create a dashboard. Then you have to create the dashboard in CloudWatch. Go to dashboard to create a new dashboard. Add widgets for each metrics to monitor entire pipeline from a single dashboard. So a single dashboard, if you write or if you say in your interview that I created a single dashboard from I watched or I monitored the entire things, entire resources. Here's the only pipeline, right? But say the entire resources, man. Your job will be very much easy, man. Then visualize data with Amazon QuickSight. quick site is for visualization. Set up data sources. Go to Amazon quick site and select manage data sources. Connect quick site to your data storage, RDS or DynamoDB for structured process data, S3 for raw or semi-processed data. So RDS or DynamoDB, keep in mind, is structured, man, or processed data. That means it should be uniform, good uniform, booted, suited, like that. Okay, not like me without the complete suit, just with a single t-shirt. Okay, speaking. So this is if not processed, if unstructured, anything else, S3 says, okay, welcome you Azizul. Okay. Yes, man, everyone is object, right? So think like that easily. RDS, DynamoDB, those guys are too much upper class, like, okay. And S3 is saying, okay, I'm open for everybody. Then create visualization. Use quick sites, drag and drop interface to create charts, graphs, tablets, and represent data insights. Example, time series for data throughput, and bar charts for error rates by region. Share the dashboard with stakeholders to provide real-time insights into data processing and system health. Step 8, enhanced security. I'm giving this one the color. Security goal: implement security best practices including least privilege. When security coming, guys, least privilege, please keep in mind. I'm making this one is red. Least privilege practice: access control and VPC configuration for secure communication. Define IAM roles and policies. Create IAM roles for MSK, EMR, Lambda, and DataSync. How many roles will be? 1, 2, 3, 4 roles, right? I'm making the color, these guys all. So 4 roles first. That means think that 4 persons, 4 people, 4 mates. So MSK role. Role will allow, throw, which one? Permission. Permission has policies. Okay. So policy like flag, permission like hand, role is like human being, like that. Okay. So to read write to S3 for data backup EMR role, allow Spark jobs to interact with MSK, and read write. See here, read write. Just memorize which role. Read write permission. Read write permission. Okay, that means everything. Oh my goodness. Then Lambda role grants permission for triggering DataSync tasks, monitoring CloudWatch, and initiating failover. Lambda for failover, right? I'm making red color this one. DataSync permission for accessing S3. So DataSync which one? Accessing S3 or other storage locations and initiating sync tasks. So accessing, then initiating tasks. Sync. I'm giving the sync red color. This one. Assign least privilege policies. Ensure each IAM role has only the minimum permissions required for its function. Example policies here: MSK only, Amazon MSK, read only access. This is one, and Amazon S3 read only access. Then Lambda access is DataSync start task execution and relevant CloudWatch actions. VPC security and cross-region communication. Set up VPC peering. So it's for 2 region, that means peering, securely connection. For cross-region data flow. Oh, this is one interview question I'm saying. When peering is coming, sometimes the interviewer just checking your knowledge. Can you connect your 2 regions without internet, without IGW internet gateway? Yes, you can do with VPC peering. So if the 2 friends are walking all together in the street, they can connect with hand to hand, right? Handshake, keeping two hands all together, then just walking, right? Walking like this way, 2 hands. Okay, so this is the peering, man. Easy. Go to VPC console peering connection and create a peering connection. Update route route tables. Then ensure subnets in both regions can communicate by updating the route table with the peering connection. Place resources in private subnets. Host sensitive resources like MSK broker, EMR nodes, and databases in private subnet to restrict external access. Use net gateway for outgoing internet traffic if necessary. Net for private subnets, So say for the sensitive data, we used which one? The private subnets, okay? I forgot to mark this one. So when private is coming, when then net gateway is coming. One simple question in the interview, simple question. Interview will say like that: you connecting from your subnets with IGW, right? But how do you connect with the private subnet with IGW or anything else from the outside of the VPC? You have to say that net gateway, because the public is only the IGW, but net is for the private subnet. Then enable VPC flow logs. Use VPC flow logs to monitor. Flow log for monitor network. Which one? Network traffic. So flow log means flow. How many traffic is coming? My VPC has lots of subnets, right? So every subnet has lots of IP address, right? So IP address, that means one IP address, one network. So how many IP address is working there, networking working there? You have to see with the VPC flow logs within an across region for auditing. You have to audit that. And troubleshooting. Configure flow logs to send data to CloudWatch or S3 for analysis. Man, this is for analysis. You have to configure. Okay, you are doing analysis a bit, not much. You just watching the streets, how many IP addresses. That means streets, ways, canals, channels, like that. How many ways, IP addresses. You just watching, but you are making configuration that flow log for data scientists. They will do analysis the data insights. So you are brother to analysts. You are not analyst. Remember, you know how to connect the analysis or analytics like that. This is very much good, important actually qualification for your job. Final project workflow summary. Data integration is here. Kafka process send data to the primary MSK cluster. Kafka mirror maker replicates data to the secondary region. So mirror maker making the replication to the secondary region. Replication, you know, in front of the mirror you can replicate. You are watching yourself. Oh, I can watch my face in the mirror. No, your face is replicated. Your face is replicated in the mirror. Then you are watching in your eye. You are watching the replication of your face. So same way, this is interesting. Kafka has the mirror maker. Is making the mirror to replicate data to secondary region. That means when failover is done, then region 2, it will be mirrored like that. So you have to do like that. Real-time processing. Spark streaming jobs in EMR cluster processes data and store it in databases with cross-region replication. Then data synchronization. AWS DataSync ensures multi-region data consistency with automated updates. Okay, multi-region data consistency. Then automatic failover, that is mirror, right? From primary to secondary MSK cluster during failures. Monitoring and visualization. CloudWatch and QuickSight enables real-time monitoring. Security, IAM and VPC controls, protect and manage secure access. I think it will be very much helpful, you guys. Please try yourself first. It will take a bit time, honestly, and it will be some source of complicated first, but if you give the time here, honestly it will be for you as diamond in your career. Also EMR is here, also elastic map reduce also added here. So you have to create the cluster also here, but EMR not taking too much time to create the cluster. You have to create the cluster from here. Okay, so guys, this is from today. Now I have to go outside. Okay guys, so see you next time. If any questions, any queries, please comment. Thank you very much. Have a good day.